Hi everyone, Darren from DrayTek Australia and New Zealand. Continuing on from our webinar series covering different features in DrayOS 5 routers, today we'll be looking at another standout feature, monitoring the router and network. We'll start by introducing the monitoring section in DrayOS 5, where we'll explain what it is and why it's important. Next, we'll explore the various monitoring features in detail so you'll understand what tools are available and how to use them effectively. Finally, we'll cover some of the built-in troubleshooting utilities, including tools like ping, traceroute, DNS lookup, iperf, and the web CLI. These are especially useful when diagnosing VPN connectivity issues or general network problems. So, what exactly is monitoring? Monitoring in DrayOS 5 is a set of built-in tools designed to help observe and analyze real-time network activity and system status. It's important because it allows quickly identifying issues, troubleshooting more effectively, and getting a clear overview of what's happening on the network at any given time. Whether you're trying to track down a connectivity issue, review client activities, or just keep an eye on overall performance, these tools make it easy to access the information you need. You can find all the monitoring tools grouped under the monitoring section in the main menu, making them quick and convenient to access. Let's go through each of these tools and explain how they can help manage and maintain the network more efficiently. First, we'll go over the monitoring features available. Clicking the monitoring heading in the left-hand menu will expand to show a selection of options. At the top, Log Center. This helps track system and network events. It's useful for reviewing historical logs and identifying patterns or issues. WAN. Here, the WAN connection status and traffic statistics can be monitored in real time, which is essential for understanding internet connectivity and usage. ARP table shows the current mappings between IP addresses and MAC addresses on the local network, which can help with troubleshooting connectivity or conflict issues. Route table allows checking active routing entries and understanding how packets are being forwarded in the network. DHCP table displays the list of IP addresses assigned by the router's DHCP server to clients, which is helpful for managing connected devices. IPv6 status and tables allows monitoring IPv6 connections and to see neighbour information. LLDP Neighbours displays information about directly connected devices discovered through the Link Layer Discovery Protocol, helping to confirm network topology and device roles. DNS cache table shows the cached DNS records so you can quickly see what domain names have been resolved recently. Remote DSL status allows the router to retrieve DSL line status from a connected DSL modem on the WAN port and display it on the dashboard. PPPoE pass-through helps track PPPoE client connections passing through the router, often used in certain ISP configurations. Session table allows inspecting all active sessions per client, which is extremely useful for detailed traffic analysis and security monitoring. Running services shows a list of services currently running on the router, including their protocol and port numbers, which is useful for operational checks and security audits. Together, these tools provide a comprehensive view of the network, allowing managing and troubleshooting effectively. Okay, let's go through those in a little more detail and what they look like in the web user interface. First up, the Log Center is disabled by default, so you'll need to enable it to start capturing logs. Then choose whether to override oldest logs or stop when full. The maximum log entries is 1000. After that, it'll start overriding the oldest logs or stop when it hits that, depending on which you choose. The log can be exported as a text file or in JSON format, or cleared if you want to start over. On the filtering pull-down option here, you can specify a type of traffic so you only see the traffic you're interested in. The default is all, but you can specify just user access, connection, WAN, LAN, system, IAM, VPN, firewall, TR069, DNS, route policy, or others not previously mentioned. The DDNS log tab can be used to see any issues with DDNS. The refresh button at the top right will show the latest information. Under WAN, you can see the WAN utilization, including upload, download, and percentage of data transmission for each WAN interface. The WAN status tab displays the WAN connection status, including the connection interface, MAC address, connection type, IP address, gateway, primary and secondary DNS server addresses, and uptime for both IPv4 and IPv6 connections. ARP table shows the contents of the ARP Address Resolution Protocol cache held in the router for both LAN and WAN, and shows the mappings between MAC addresses and IP addresses. Route table displays all the routing entries that determine how packets are forwarded within the network. This is very useful when you want to understand or verify how traffic is being routed. On this page, we can see both IPv4 and IPv6 route tables. Starting with IPv4, the table lists details such as interface, which is the interface used to forward the traffic, for example WAN1 or LAN1 in this case. Destination, the destination network address or IP range. Mask, the subnet mask that defines the network portion of the address. Gateway, the next hop IP address if needed, or marked as directly connected when no gateway is required. Flags, this shows whether the route is static, connected, or default. You can click refresh on the top right to reload the page and get the most up-to-date routing information. IPv6 is similar but displays entries specific to IPv6 addressing. This helps administrators manage dual-stack environments where both IPv4 and IPv6 are in use. Having access to this routing information makes it easier to verify correct configurations, troubleshoot reachability issues, and ensure that the network is forwarding traffic as intended. Under DHCP table, first there's the IPv4 DHCP subnet page. This displays the DHCP server status for each LAN interface, including details like the IP range, the configured IP pool, how many IP addresses have been used, and the overall percentage of utilization. This is very useful for understanding if the DHCP pool is running low and whether adjustments are needed to avoid conflicts or shortages. The IPv4 DHCP lease page shows a list of devices that have obtained an IPv4 address from the router, along with the remaining lease time for each device. This makes it easy to track which devices are currently active and when their lease will expire. The IPv6 assignment page is similar to the IPv4 DHCP lease page. It shows the remaining lease time for devices that have received an IPv6 address from the DHCP server. This is particularly important for networks using dual-stack configurations or transitioning to IPv6. Together, these three tabs provide a clear picture of how IP addresses are being allocated and used across the network, allowing for better control and easier troubleshooting. The IPv6 TSPC status page is designed to help monitor and diagnose IPv6 connections that use the Tunnel Setup Protocol Client or TSPC. TSPC is typically used when you need to establish an IPv6 connection through a tunnel broker, allowing IPv6 connectivity over an IPv4 network. If TSPC is configured correctly, the router will show the status information here, confirming that it has successfully connected to the tunnel broker. This is especially helpful when troubleshooting IPv6 connectivity issues, as you can quickly verify whether the tunnel is up and operational. You can also click refresh on this page to reload and get the most up-to-date connection status at any time. Overall, this page provides a straightforward way to ensure your IPv6 tunnel setup is working as expected. Moving on to the IPv6 neighbour table page, here we can see mapping between Ethernet hardware addresses, also known as MAC addresses, and their corresponding IPv6 addresses. This information is very useful when diagnosing network problems, such as an IP address conflict or communication issues between devices. You can easily see which IPv6 address is assigned to which physical device on your network, helping to verify correct assignments and identify any unexpected or duplicate entries. The IPv6 neighbour table provides clear visibility into Layer 2 to Layer 3 mappings in your IPv6 environment, making it a valuable tool for network troubleshooting and management. The LLDP Neighbours page displays information about directly connected devices discovered via the Link Layer Discovery Protocol (LLDP). It shows details such as the local port on the router, the neighbour device's chassis ID, system name, system description, management IP addresses, IPv4 and IPv6, system capabilities, port ID, port description, and timing information. This information is useful for identifying connected devices, verifying network topology, and troubleshooting physical connectivity issues. You can easily see which devices are connected to which ports, confirm device roles and capabilities, locate their management IP addresses for configuration or monitoring. On the DNS cache table page, you can view all the DNS records currently cached on the router. The router can function as a DNS server for LAN clients, meaning that devices on the local network can send their DNS requests directly to the router. When the router receives these DNS requests, it temporarily stores or caches the DNS information to speed up future lookups and reduce external DNS traffic, and there's tabs here for both IPv4 and IPv6. By checking this information here, you can verify which domain names have been recently resolved, which can help when diagnosing connectivity issues or unexpected traffic patterns on the network. Next, the remote DSL status page allows the router to receive DSL modem status information from the WAN port. When this function is enabled, the router collects the DSL status from the connected DSL modem and displays it on the dashboard. This is useful when your DSL modem is operating in bridge mode or is separate from the router, as it allows monitoring the DSL connection without logging directly into the modem. The PPPoE pass-through page offers support for PPPoE dial-up connections, which are commonly used to connect to many ISPs. In addition to the router establishing the PPPoE connection directly, local clients on the network can also initiate their own PPPoE connections through the router, which is referred to as PPPoE pass-through. When the PPPoE protocol is selected, the PPPoE packets sent by the PC are transformed into PPPoE packets by the router and then forwarded to the WAN server. This allows individual PCs to directly establish and manage their own connections to the ISP while still passing through the router. This page displays the current results and status of any PPPoE pass-through connections, making it easier to monitor active sessions and diagnose any connection issues. Moving on to Session Table. This page displays the NAT Session Table, which shows detailed information about active connections passing through the router. Here you can see various fields, including interface, the interface handling the session, source IP and source port, the originating device and port, pseudo port, the NAT translated port used by the router, destination IP and destination port, the target device or server, and port number. Protocols such as TCP or UDP, state, the current state of the session, for example, established or closing, TTL, time to live value for the session. You can display up to 200 entries at a time, and clicking refresh up the top right reloads the list to show the most current session data. This table is especially useful for diagnosing connection issues, checking which devices are actively using the network, and verifying if your firewall or NAT settings are working as intended. Even though this example currently shows no records, during real operation you would see many entries here representing active flows. This provides deep visibility into real-time traffic and helps ensure the network is operating securely and efficiently. And finally, the Running Services page displays a list of the network services currently running on the router, along with their associated protocols and port numbers. Common examples include SSH, Telnet, DNS, TCP and UDP, DHCP, HTTP, and HTTPS. By reviewing this table, you can see which services are active, the protocol they use, and the port they're listening on. This information is useful for verifying that required services are running, ensuring there are no unexpected or unnecessary services enabled, and checking which ports are open for remote or local access. The refresh button can be used to update the list and display the latest status of the running services. Now let's take a look at the utility menu. While the monitoring tools provide valuable insights into what's happening on the network, sometimes it's necessary to actively diagnose and resolve issues in real time. The utility menu in DrayOS 5 provides a set of built-in tools designed to help quickly identify and fix connectivity problems. Some of the key tools include ping, traceroute, DNS query, iperf, and web CLI. These allow testing reachability, checking routing paths, resolving domain names, and even executing commands directly on the router, which allows effectively pinpointing issues without needing additional external tools, which saves time and effort. Let's go through each of these in more detail and see how they can help keep a network running smoothly. Under the Network Tools option, you'll find Ping, which sends test packets to a specified IP or hostname to check connectivity and measure response time. Useful for basic network troubleshooting. Traceroute shows the path packets take to reach a destination, listing each hop along the way. Helps identify where delays or connection failures occur. DNS queries DNS servers to resolve domain names to IP addresses or vice versa. Includes options like NS lookup and DNS security for reliable and secure lookups. iPerf measures network throughput between the router and an iPerf server. Helps test bandwidth performance over TCP or UDP. Let's check these out in more detail. Starting with the Ping tool, which is found under Utility, Network Tools in the first tab. This allows sending ping requests to a specified IP address or host directly from the router. By doing this, you can quickly check if the data transmission to a particular device or external server is working properly through the router. It helps verify connectivity, measure response time, and detect packet loss, all of which are essential for diagnosing basic network or reachability issues. Using the ping tool from the router's perspective can also help isolate whether a problem lies within the local network, at the router, or further upstream with the ISP or destination server. To use it, select either IPv4 or IPv6. You can choose which interface you want it to go out through. Choose an IP address, for example Google DNS 8.8.8.8, packet size, how many packets you want to send, and the ping interval. Then just click Run. And there's the result. Next tab is the Traceroute tool. This allows performing a traceroute to a specified IP address or host directly from the router. Traceroute helps to see the path that packets take from the router to the destination, showing each hop along the way and the response time for each one. By using Traceroute, you can identify where delays or failures occur along the route. For example, whether an issue is within your local network, at the ISP, or further out on the internet, which makes it a powerful tool for diagnosing data transmission problems and understanding the overall network path taken by traffic. To use it, once again, you have a choice of IPv4 or IPv6, and you can select the interface to go via, protocol, ICMP or UDP, the trace counts, and the maximum number of hops you want to see. Then click Run. And there's the result. The DNS query tool allows diagnosing and verifying DNS functionality directly from the router. You can use it to query DNS servers and obtain either domain name or IP address information. There are two available methods you can choose from: NS lookup, short for name server lookup. This method lets you check how a domain name is resolved to an IP address or vice versa. It's very useful for basic DNS resolution tests. Just enter a host or IP address, then click Run. Okay, let's try again with a host name. And the other method is DNS security. This adds an extra layer of security by ensuring the DNS response's reliability, integrity, and confidentiality. This is particularly important when you want to confirm that the DNS data hasn't been tampered with and comes from a trusted source. Let's click Run and see what we see. And there's our result with lots of handy details. Lastly, the iPerf tab. This tool is used to measure network throughput between the router and a designated iPerf server, allowing you to test and verify the performance of your network connection. From here, you can choose the iPerf version, iPerf or iPerf 3, and the IP version, IPv4 or IPv6. You'll need to specify the server address or IP address, and optionally the server port, bandwidth, and packet length for the test. Additional options include measurement time, the duration of the test in seconds, protocol type, choose between TCP and UDP, Interval sets the reporting interval during the test. Bidirectional test enables testing in both directions to measure upload and download performance. Once all the parameters are set, click Run to start the test. The results will help identify whether any throughput issues are caused by the local network, the WAN link, or further upstream. To test it, let's first open a command prompt. Here the iPerf listening server is 192.168.1.22. Go to the iPerf3 folder and use the iPerf3-s command to start listening. Now back to the 2136, we'll be using iPerf3 for this demo. For IP version, we'll use IPv4, and server address will be 192.168.1.22, and use the default server port, which is 5201. Bandwidth and packet length just leave blank unless you need to be specific. Likewise with the rest of the settings. They can also stay at their defaults. Then click Run. And there's the result. Finally, let's talk about the Web CLI, also known as the Web Console. With this tool, there's no need to use telnet commands to manage the router. The Web CLI allows you to execute command line instructions directly through your web browser. Any changes you make here will have the same effect as those made through the standard web user interface, and you can also review those changes later in the GUI. This tool is especially useful for advanced users who prefer using command line commands for quick configurations or diagnostics, but still want the convenience and accessibility of a web interface. Overall, the Web CLI combines the flexibility of command line control with the ease of browser-based access, making it a powerful addition to your troubleshooting toolkit. So go to Web CLI from the menu. First, we need to log into the router. Okay, let's try a few commands. Exec date will show the time and date and system time of the router. Exec sysinfo will display all of the system information of the router. Exec ps shows related information about programs processing. Exec mem displays memory usage. Exec reboot _ system will reboot it. We get prompted here to enter 0 to retain the current settings or 1 to reset everything to the factory defaults. Okay. So this is the end of today's session. In summary, we began by introducing the monitoring features in DrayOS 5, which assists in observing and analysing real-time network activity and system status. We then went through each monitoring tool in detail, including the log center, WAN status, ARP and route tables, DHCP information, IPv6 tools and LLDP neighbours, DNS cache table, PPPoE pass-through, remote DSL status, session table, and running services. After that, we explored the utility menu, where we looked at practical tools such as ping, traceroute, DNS query, iPerf, and the Web CLI. These tools allow quickly identifying and resolving network issues directly from the router. By using these monitoring and troubleshooting features together, you can maintain better visibility and control over your network, ensuring smoother operation and faster problem resolution. Okay, that's all for now, but please stay tuned. If you have any questions, we'll be available in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please select all from the subscribe drop-down menu as well. Thanks and bye for now.